Hello everyone, hello children. This is Tobrit here. Uh, as we have started the initiative of having online classes, without wasting much time, we got to start with the very first chapter, that is chemical reactions and equations. Okay. So before going into the details of the chapter, what we need to understand is why we need to represent the events occurring in our day-to-day lives in terms of chemical reactions. Okay. So is it that when I tear a piece of paper, I represent it in the form of equation? No, isn't it? So chemical equations are required for those events or those processes where chemical transformation takes place. Now, what is a chemical transformation? Now, to understand this properly, and later we'll go into the details of the chemical reactions and equations. So, to understand this properly, why we need to talk about chemical reactions, we got to differentiate about physical changes and chemical changes. Now, if I take a piece of paper, as you can see here, if I take a piece of paper, if I tear this apart, okay? So if I tear this piece of paper apart, what is happening? Tearing a piece of paper. What is happening when I am tearing the paper pieces? The chemical composition of the paper is remaining the same, as you can see. Okay, this is also a piece of paper, this is also a piece of paper. So what is happening? The molecular arrangement or the atomic arrangement does not change. New species is not formed in this process. So this type of process is called a physical process or a physical change. Okay. On the other hand, what I can do is I can burn this piece of paper. I can burn this very piece of paper. So if I burn this, so burning in terms of chemistry is called combustion. So if I burn this piece of paper, combustion of paper. So what will happen? What will you get? This will burn and it will burn into acids. So you will get acids. Now, this is a chemical change. Why it is a chemical change? Because the paper has been converted to some other entity which is here S. Okay. Now, let's talk about another example. So say we are trying to convert water into ice. So what do you think? Is it a physical change or a chemical change? So this is a physical change. Why it is a physical change? Because it is just when water is being changed from water to ice, only the dimensions are changing, only the state is changing. Dimension means shape, size, etc. Okay, so water is being converted to ice. After all, we know that water exists in 3 states. So water and ice, they basically represent the same molecular arrangement. But same molecular, you can say not the same molecular arrangement, but they are made up of the same entity, that is hydrogen and oxygen. So here what is happening when water is being converted to ice? The change is a physical change. It's not a chemical change. Okay. Here we are not getting another new substance is not being formed. Okay. So in a chemical change, what is the major point? New substance is formed. Whereas in a physical change, no new substance is formed. So the size of the board is very small, so you have to adjust it, just like I am adjusting. So now let me take another example, a very classic example as such. So classic example in the way, suppose you are breathing. So I am considering respiration. Okay. So what is respiration? Everyone respires, right? So suppose you are respiring. So when you respire, what does it mean? Is it a chemical change or a physical change? Now what happens? You take in oxygen, you give out carbon dioxide, right? Isn't it? You take in oxygen, you give out carbon dioxide. So you are taking in oxygen and you are giving out carbon dioxide. So these two are two separate entities. So here the transformation of oxygen to carbon dioxide is taking place. So this is not a physical process. This is a chemical process where oxygen is being converted to carbon dioxide. So did you understand the difference between physical and chemical processes? So when we discussed about burning of this paper and when we discussed about this respiration, these are chemical processes, and these chemical changes, okay, these chemical changes are represented in the form of chemical reactions or chemical equations. Okay, that is the language of chemistry. Are you getting my point? So now, after having introduced this, let me have a quick introduction about how the chemical equations or reactions are represented. So as everyone must be familiar with chemical equations and reaction, we have reactants, they react with one another to form products. Okay. Okay. So any external parameter. So here I am representing. This is a representation of a chemical reaction. Any representation of a chemical reaction is done in this way. So if we have to introduce the name of catalyst, if we have to discuss about the temperature, pressure, etc., which is required for the reaction to proceed, we show it on this arrow. Are you understanding? So this you will see later when we continue with our discussion on chemical reactions. So basically what we have learned, we are in a state where we can now discuss about chemical reactions properly. All the chemical processes can be represented in the form of chemical reactions, and there are infinitely many chemical reactions which occur in our day-to-day life. Okay, for example, how is water formed? Water is formed when hydrogen reacts with oxygen. Everyone knows hydrogen reacts with oxygen to form water. Now, we are science students, we don't have time to write all this blah blah blah. So what we do is we represent this statement in the form of equation. Okay, so here comes the language of chemistry. Hydrogen represented, it has a diatomic existence, H2. Oxygen, O2, it will form water. Now here in the left hand side you can see 2 atoms of hydrogen are there. In the right hand side we have 2 atoms of hydrogen. Left hand side 2 atoms of oxygen, and on the right hand side only 1 atom of oxygen. So we need to balance this reaction. Why we need to balance the reaction, I'll talk about that in details in the next class. This is just an introductory class. So just to give you a gist, this is how we balance. So now you can see 4 atoms of hydrogen, 2 to the 4 atoms of hydrogen, 2 to the 4 atoms of oxygen. Oh sorry, there's a mistake. So we don't need 2 here. So 2 atoms of oxygen here. Okay, so this is a very simple method of representing a chemical reaction. Okay, so now there are different types of reactions, different conditions which are required for the reaction to proceed. So in details I'll be discussing about this chemical reactions and equations in details in the next video lecture. So till then, thank you, enjoy, stay safe.